This is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 7 topics. And the first topic is about the EU with its ban of privacy coins on regulated platforms. It's the following article here. The European Union is implementing new anti-money laundering regulations that will ban privacy-preserving cryptocurrencies and anonymous accounts starting in 2027. Under the anti-money laundering regulation rules, crypto service providers, banks, and financial institutions must stop handling privacy coins like Monero or Zcash. They also cannot keep any anonymous crypto accounts. The ban covers any accounts that hide transaction details or use privacy-enhancing coins. This affects especially Monero and Zcash as mentioned here. These regulations are now final, with implementation details still being worked out. Centralized crypto service providers need to update their internal rules to follow these new regulations. The European Banking Authority will handle most of the technical implementation through specific acts. All crypto service providers must perform customer checks on transactions above 1,000 euros. These changes build on existing crypto regulations like MiCA. This does not affect your private coins, only those on regulated exchanges, but it gets more difficult to trade privacy-preserving coins like Zcash or Monero. And I want to reiterate that centralized platforms such as with Terra Luna, Mt. Gox, FTX also had issues, so don't forget, not your keys, not your coins. The next topic is about simplicity. I like simplicity, and AWS is not particularly known for simplicity. This article is about how a security firm found an issue when following the AWS documentation. AWS built a security tool called Account Assessment for AWS organizations that was meant to check for risky cross-account access. However, AWS' own deployment instructions accidentally created security risks. The tool uses a hop and spoke design, where a hop role in one account can access spoke roles in all other accounts to audit security across an organization. AWS told users not to put the hop in the management account, but didn't explain which account to use instead. Many customers followed AWS guidance by placing the hop in development accounts, which typically have weaker security than production or management accounts. This created a privilege escalation path where anyone who compromised the development account could access sensitive production and management accounts. After the security firm reported the issue, AWS updated their documentation to explicitly recommend deploying the hop in high security account that matches the sensitivity of accounts being assessed. Complexity is good for selling services, and it also means vendor lock-in. However, managing security, as you can read here in this article, may become more difficult the more complex the system is. The next topic is about the blackout in Spain and Portugal I mentioned in previous weeks. On April 28th, Spain and Portugal experienced major power outage that disrupted services across Spain and Portugal. However, data from web traffic monitoring showed how distributed systems helped some people stay connected during the crisis. And here we see the first graph. This is from Akamai. We see here the time. So this is the usual pattern. During daytime, we have traffic. During nighttime, not that much. And here we see the drop due to the power outage. The outage started at 12:33 p.m. in Spain and 11:33 in Portugal, lasting around 2 in the morning the next day. And despite 80% drop in desktop traffic, mobile traffic only decreased by 40%, with more people using mobile devices than desktops for several hours after the outage began. During the blackout, people switched from Wi-Fi and wired connections to cellular networks. Portugal saw cellular network usage increase by 30% points, while wired connections dropped significantly. Several wireless hotspots also appeared during this time. And this we see in the following graph here. Here we see the sudden drop. The yellow one is the mobile and the blue is the desktop. Of course, desktop PC, if it doesn't have power, it cannot connect internet, while your mobile device still has battery and still can access the internet. And these traffic patterns reveal what services people in Portugal and Spain use during the emergency. In Portugal, news websites saw immediate increases as people were looking for information. Food safety websites received traffic for the first time in weeks as people worried about refrigerators. Government websites experienced periodic spikes for updates, while retail, entertainment, and financial activity dropped. This we see in the following article here. The red one is news and the blue here is government. Spanish users showed different priorities, with government websites being their main information source rather than news sites. Travel websites maintained steady traffic as people checked if their plans were affected. And this is also an interesting view. Here, these graphs show the battery percentage of those users in Portugal and Spain. And we see that battery levels dropped about 10% points lower than normal during peak outage hours. As power returned in stages, first in Portugal, then in Spain, battery level gradually returned to normal patterns. And despite widespread power failure, many online services remained accessible through distributed edge servers with backup power and geographic redundancy, allowing people to access critical information when they needed it. The next article is about the Skype shutdown. Skype is shutting down on May 5th, or has shut down on May 5th, 2025, after 23 years of connecting people worldwide. Microsoft, which owns Skype, will close the service completely on this date. Users have two options: migrate to Microsoft Teams or download their Skype data. Teams automatically transfers all contacts and chat when users log in with their Skype credentials. Teams offers more features than Skype, supporting up to 10,000 participants compared to Skype's 20-person limit, and includes business tools like integration into Office 365, Salesforce, and Trello. For those not moving to Teams, Skype provides export options for contacts, caller ID numbers, files, and chat histories. Users can download this data through Skype's settings menu before the shutdown. And several alternatives exist for video calling. Google Meet is free with the Google account and supports for 100 participants. And Zoom offers similar features with a 40-minute limit on free plans. Discord works well for personal use and smaller teams with up to 25 participants. Slack offers spontaneous video calls through its huddle feature, and Signal provides encrypted video calling for up to 50 participants and is also completely free. WhatsApp, Facebook Messenger, and Apple FaceTime remain options for mobile users making calls with smaller groups. The shift from Skype to Teams represents Microsoft's move towards WebRTC-based solutions. Most of these other solutions I mentioned, they use WebRTC, and in the WebRTC lecture here, I asked WebRTC, is this a Skype competitor? Yes, it is. It even killed Skype. The next article is about passwords and security, which I also covered here in lecture 8. Here, this study from Hive shows that password cracking time have decreased in 2025. The AI hardware boom has dramatically accelerated computing power available to attackers, making previously secure passwords vulnerable much faster than before. Password cracking speeds have increased by 20% compared to 2024 using consumer-grade GPUs. An 8-character password with only lowercase letters can now be cracked in just 3 weeks, down from a month last year. The computing power gains are even more dramatic when considering AI hardware. The article links to the following site. This is the Hive system password site, and this table, this shows that when using 12 NVIDIA GeForce RTX 5090 GPUs for the baseline of the calculation, how much time is needed here for breaking or brute forcing passwords with the following amount of characters here. And the RTX 5090, they represent the most powerful consumer graphic cards currently available. And the research uses bcrypt, as many of our students as well, as the hash function with a cost factor of 10, reflecting real-world implementations. Current recommendations suggest users need at least 13 characters passwords to remain secure. With the powerful hardware setup, a 13-character password would take approximately 56 billion years to crack through brute force. However, an 8-digit PIN can be compromised in just 15 minutes with the same hardware. If attackers had access to enterprise-level AI hardware like 20,000's A100 GPUs used to train GPT-4, even stronger passwords become vulnerable. With such resources, a 10-digit password with mixed characters would take only 112 years to crack, while a 14-digit password with full complexity would require 52 billion years. The analysis assumes worst-case scenarios where attackers use pure brute force methods. Real attacks often succeed faster using dictionary tags, rainbow tables, or databases of previously compromised passwords. The next article is about supply chain attacks. It's the following article here. This seems to be an increasing trend. A new supply chain attack has been discovered targeting Linux users through malicious Go modules hosted on GitHub. Security researchers found 3 dangerous packages containing obfuscated code designed to download and execute disk-wiping malware. Those 3 packages here. The attack campaign was discovered in April 2025 by a security company. The 3 malicious Go modules impersonated legitimate tools and contained heavily obfuscated code. When executed, this code downloads a bash script called don.sh that destroys all data on affected systems. The destructive payload specifically targets Linux environments by checking if the operating system is Linux before executing. It then uses the dd command to overwrite every byte on the primary storage volume def SDA with zeros, completely destroying the file system, operating system, and all user data. Though if you use NVMEs, which most people do these days, this won't do any harm locally. The malicious modules were designed to look like legitimate projects. They pretended to be a tool for converting message data formats, a Go implementation of the model context protocol, and the TLS proxy providing encryption for servers. All three packages have since been removed from GitHub. Security experts warn that even minimal exposure to these modules can result in complete data loss. The payloads execute immediately after download, leaving virtually no time for response or recovery once the attack begins. So this is another reason to use containers also during development. Such thing, if not exposed, could not happen. The last article is about hardware performance. It's the following article here. High performance CSV, comma-separated value parsing library achieved 21 GB per second parsing speed on AMD's latest processors. And this library leveraged the vector extension AVIX with 512 bits, but faced challenges with .NET suboptimal code generation for mask registers. The solution was a hybrid approach to use AVX 512 and 265. This article is quite technical, but understanding these performance metrics where a single-threaded parsing reaches 21 GB per second for low-level parse, that means no real workload, and multi-threaded hits roughly 8 GB per second, as they mentioned down here, for practical workloads. So here we have multi-threaded power, 1 billion rows in 72 milliseconds, achieving 8 GB per second for real-world comma-separated value workloads. And this provides important context for evaluating system performance capabilities in distributed computing, so you get a feeling of how fast a service should be. Good, that's it from my side. So in short, computers and CPUs today are really fast, and I will talk in my upcoming lecture a bit about performance. So see you next week.